Welcome to the review lesson for the topic of space. We'll start off with some do now questions. So in your booklet, answer these questions. When you've answered them, unpause the video and then come back and check your answers. Okay, so we'll go through the stages of a main sequence star of mass similar to our Sun. Okay, so it starts off with a nebula. Let's select a pen first. There we go, nebula. Okay, that is going to change into a protostar. So the cloud of gas and dust is going to collapse, starts getting warmer, starts glowing because of the heat, and then when the fusion of hydrogen takes place, we get a main sequence star. Okay, when it's run out of hydrogen, that main sequence star is going to turn into a red giant. Okay, so it's going to cool and swell. Okay, after it's a red giant, it's going to run out of the light elements, so everything up to iron. Okay, and it's going to change into a white dwarf. Okay, following this, it's going to turn into a black dwarf. Okay, list in order the stages of the main sequence star of mass greater than our Sun, include both end stages. Okay, so the first three stages are the same, so it's nebula into protostar into main sequence. Okay, you'll have space to type those in on your sheet. Okay, and then after the main sequence stage, when it runs out of hydrogen, it's going to turn into a red supergiant. Okay, and it's going to be fusing everything up to iron. Okay, after the red supergiant stage, it's going to run out of the light elements. It's going to have fused all the iron. It's going to then collapse and explode in a supernova. Okay, at this supernova stage, it ejects loads of material into space. Okay, so all our heavy elements like uranium and platinum, they'll be ejected into space. Okay, after this, we're going to get a neutron star. Okay, for our heavy stars, our super heavy stars, really, really heavy ones, we're going to be turned into a black hole. Okay. Alright, so describe the forces acting on the star in the main sequence. Okay, so we've got gravity and gas pressure are equal, so the star is stable. Okay. Okay, so the forces are equal. The gas pressure comes from the hot gases, basically. Okay, and they're trying to push out, and the gravity is pulling it in. They're stable, so the star stays the same size. Why does the star move from the main sequence to a red giant? Okay, as we already said, it runs out of hydrogen. Okay. What element is fused by stars in the main sequence stage? Okay, hydrogen. Alright, at what stage are elements heavier than iron formed? Okay, that's the supernova. Okay, and finally, what does the Hertzsprung-Russell diagram show? Okay, it shows us stars according to their temperature and brightness. Okay, and we can use that to group our stars into the different stages. Okay, so we get our main sequence, get our red giants, we get our red supergiants, and then we get our white dwarfs. Okay, right. So pause the video if you need to write any of those in. Please do that now. I'm just going to correct some little bits of just not very neat. Well, I think I'm too close to the edge of the page there. Okay, so today we're going to be, you're going to producing a review sheet and producing high quality answers to exam questions. Okay, so there's our nod of words and our learning journey. Okay, so let's get on with the main part. Okay, so let's start here. Name the main features of our solar system. Okay, so we need to think about what do we find in our solar system. Okay, so you are, of course, going to pause this at any point if you need the answers. You should be trying to complete this on your own. All right, so in our solar system, we have the sun. In any solar system, there'll be a star at the centre, or sometimes there's two, but we'll just stick to one. Okay, orbiting the star is our planets. Okay, and orbiting those planets are moons. Okay, we also have asteroids. And comets. Okay. We'd also have man-made objects like satellites and space probes, but we don't have to talk about these. Okay. So what makes up our universe? Okay, so we get stars and solar systems. Okay, and they're grouped together in clusters. We call those clusters galaxies. Okay, our galaxy is the Milky Way. Okay, but there are millions of other galaxies. Okay, we get clouds of gas and other materials ejected from the supernova. Okay, and finally we get space and energy. Okay, it's important that we remember to talk about space and energy because they are part of our solar system. Okay, of our universe. Right, so astronomical units. What do these words mean? Astronomical units. Okay, it's the average distance between the Earth and the Sun. Okay, because it's such a huge distance, we use this so we can compare the numbers quite easily. Okay, it also makes graphing easier, and it's just a nicer set of numbers. Okay, so the average distance between the Earth and the Sun is approximately 150 million kilometers. Okay, right, a light year is just simply the distance light travels in a year. Okay, so we know how fast light travels in a second. We simply multiply that distance by the number of seconds in a year, and that gives us a distance. Okay, it's an absolutely huge number. We use this when we talk about stars, the distance to other stars. Okay, so our next nearest star is about 4 light years away. Okay, and it's much easier to talk about that rather than talking about it in kilometers. Okay. All right. Okay, so pause that there. If you need to write anything in. Okay. What causes a star to form? Okay, so a cloud of gas contracts under gravity. Okay, it heats up until fusion of hydrogen starts forming the star. Okay, until hydrogen starts fusing. Okay, and that's where the energy from the star comes from. Okay, what causes the star to reach its final stages of life? Okay, so we're talking about the end of the red giant stage here, so the stars run out of light elements. Oh, goodness me. Let's try that again. There we go. All right. So, pause that there. Okay, so you should be able to read those. You can go back over it. What causes a star to form? It's a cloud of gas that contracts under gravity. It heats up, and then the hydrogen starts fusing. What causes the star to reach its final stage of life? The red giants and the red supergiants run out of light elements to fuse. Okay, right. Label the following sections on the Hertzsprung-Russell diagram. Okay, so we've got the sun is this one here. So we can just label that as the sun. The main sequence is this whole bit here. Okay, red giants are these just here. These are our red supergiants. Okay, and then this bit down here are our white dwarfs. Okay, so a main sequence star, such as our sun, is going to turn into a red giant, and then it's going to cool to become a white dwarf, and it's slowly going to get cooler and cooler. Okay. All right. So let's move on to the next question. How did the solar system form? Okay, so material ejected from supernovas joins up with other dust and gas, hydrogen, and begins the process of star formation. Okay, the other materials, so they're not hydrogen gas bits, they're going to form into planets. Okay, the more dense the material is, the closer it's going to be to the sun. Okay, and that's why we get our rocky planets close to the sun and our gas giants away from the sun. Okay, so let's write that in. Okay, so you might want to pause that there to make sure you get the correct answers, and then finally we're going to go over and we're going to look at this part. Okay, so it says list the stages in the life cycle of a star. One for the low mass star, so that's going to be this side, the low mass star, and one for the large high mass star, okay, over this side. All right, so I'll do the low mass star. You can see I've already started. So a cloud of gas and dust forms, and due to gravity it starts collapsing. Okay, a protostar is formed as nebula collapses. The temperature and the pressure increases. Okay, 3, we get our main sequence. Okay, we get fusion of hydrogen. Okay, number 4, the star runs out of hydrogen. Okay, so star so it cools and swells to form a red giant. Okay, number 5, it's going to runs out of light elements. Okay, so that's from helium up to iron. Okay, Okay, it's going to contract to form a white dwarf. Okay, as it continues to cool, okay, it goes from being a white dwarf to a black dwarf. Continues to cool and forms a black dwarf. Okay, right, I'm going to change colour to red for the other star. You can pause that there and write those bits in. Okay, so high mass star, so second we've got protostar. Third main sequence. Okay, those stages are the same. Okay, so number 4 is the same, but instead of forming a red giant, it forms a red supergiant. Okay. Okay. Now, when the red supergiant, runs out of light elements, okay, again iron, okay, the core collapses. Okay, so the details are still the same. Yeah, it runs out of light elements, which is the helium to the iron. It's not going to contract to form a white dwarf. It's going to contract and then explode. Okay. In a supernova. No, I can't fit that in there. Okay. In a supernova. Alright, so now we've got two options. Okay, so it's either going to form, so the core contracts to form a neutron star, or it continues to collapse to form a black hole. Okay. All right. So there's our review sheet. Okay. Pause it as you're going through. Also, at the end of the video, there's a copy of this, so you'll be able to look at that, and that will give you your answers as well. Hopefully, that's helped you with your review sheet. Okay, so get that filled in. There are also some review questions that I'd like you to complete and fill in. So use the information in the middle here, okay, to answer these questions around the outside. Okay, this is your core knowledge. Okay, and finally, second part of the core knowledge, answer these questions using this information in here. You might not need to use the information, you might be able to just answer those questions. Okay, and finally, there is your completed review sheet. Okay, right, thank you very much for watching. Good luck with your review sheet, and then good luck with your following test.